Hello everyone, welcome to my channel Education for Aspirants. Today we will discuss how to design a DFA which checks the given binary string is divisible by 3. Okay, so see here, when a number is divisible by 3, then what are the remainders it will produce? For example, let the binary digit is 0. So 0 decimal value is how much? 0. 0 modulus 3 equals to 0. Similarly, let the binary digit is 110. The decimal value is 6. 6 modulus 3 equals to 0. Let us consider the binary value is 111. So here the decimal value of this binary value is, that is 7, right? 7 modulus 3, that is 1. Similarly, let the binary value is 101. So 101 decimal value is, that is 5, and 5 modulus 3, that equals to 2. So from this we came to know that when we will divide a number by 3, it will produce 0 as a remainder when it is completely divisible. Otherwise it will produce 1 or 2 as a remainder, right? Due to this, at the time of designing DFA, we will take our set of states as Q equals to Q0, Q1, Q2 and Q3. Clear? Q0 is our initial state, Q1 is our 0 remainder state, means when it is completely divisible, we will reach at the final state. So we will consider Q1 as our final state. Q2 is 1 remainder state and Q3 is our 2 remainder state. Clear? Similarly, though a binary string, it is the collection of 0 and 1 bits, hence our sigma is 0 and 1. Clear? Now with this information, we will move to design the DFA. So first we will take the initial state as Q0, then we will consider 3 different states, that is Q1, Q2 and Q3 to represent 0 remainder state, 1 remainder state and 2 remainder state. So Q1 is our 0 remainder state, Q2 is our 1 remainder state and Q3 is our 2 remainder state. Okay, then though it is a DFA transition diagram, hence inside the transition diagram every state must consume both the inputs, that is 0 and 1, right? So now if you read 0 as the input on Q0, then so the string will become 0, right? So you know that 0 modulus 3, how much? That is 0, means you will move to the 0 remainder state, right? Because it is producing 0. So what is our 0 remainder state? Q1. So that's why on Q0, if you read input 0, then it will come to the Q1. Similarly, on Q0, if you read 1 as input, so 1 modulus 3 equal to how much? That is 1, means on Q0, if you read 1 as input, then it will move to Q2. Now, if you read the input 0 on Q2, then the string will become 10. 10 decimal value equal to how much? 2. So 2 modulus 3, that equal to 2. So what is our 2 state? Q3, means on Q2, if you read 0 as input, then it will move to Q3 state. I hope everybody understood. Now on Q2, if you read 1 as input, then the string will become 1 1, right? Because Q0 to Q2 1, then again 1, means if you read 1 1, then binary value of 1 1 is 3. 3 modulus 3, how much? That equal to 0, means you will move to the 0 remainder state. So 0 remainder state is Q1. If you read 1 as input on Q2, then it will come to Q1 state. I hope everybody understood. Now, so if you read 0 on Q1, then the string will become 0 0, right? 0 0 or 1 1 0. Clear? Like this you will get. So 0 0 decimal value is 0 and 0 modulus 3 equals to 0. Similarly 1 1 0, the decimal value is 6. 6 modulus 3 equal to also 0. Means we came to know that on Q1, if you read 0, then you will stay on Q1 only, because Q1 represents the 0 state, right? So if you will make a self loop on Q1 by reading the input 0, then we will stay on Q1 only. Hope understood? Now we will discuss if you read 1 on Q1, then the string may occur as 111 or 01, right? So if it is 111, then the decimal value is 7. 7 modulus 3, that equals to 1. Similarly, if it is 01, the decimal value is 1. 1 modulus 3 equal to 1. Means in both cases, it is reaching to one state. So what is our one state? That is Q2, right? Means on Q1, if you read 1, it is moving to Q2. So if you read 1 on Q1, then it is moving to Q2. I hope everybody understood. Now we will discuss for the state Q3. So on Q3, if you read 0, the string will form as 100, right? The decimal value of 100 is 4 and 4 modulus 3, that equals to 1, right? So what is our one state? One state is our Q2. So that's why if you read 0 as input on Q3, then it is moving to Q2. Similarly, if you read 1 on Q3, then the string will form as 101 or it will form as 10001, right? If it is 101, the decimal value is 5. 5 modulus 3 equals to 2. Similarly, if the string is 10001, then the decimal value is 17 and 17 modulus 3 equals to 2. Means in every case it is ending at 2 remainder state. What is our 2 remainder state? That is Q3. So it implies that if you read 1 as input on Q3, then it is ending at Q3 only. Clear? So now it is the complete DFA figure because every state consumed both the inputs 0 and 1, right? Now we will design the transition table for the transition diagram. So in the transition table also we will take 4 states and 2 inputs 0 and 1. Then we will fill all the states by taking the transition information from the transition diagram. Okay. So Q0 to 0, that is Q1. Q0 to 1, that is Q2. By reading 0 on Q1, that is Q1 only. By reading 1 on Q1, we are moving to Q2. Clear? Similarly, by reading 0 on Q2, we are moving to Q3, right? By reading 1 on Q2, we are moving to Q1. Then by reading 0 on Q3, we are moving to Q2. So this is Q2. By reading 1 on Q3, we are staying at the same state, that is Q3. So that is Q3. Clear? So here in this figure, Q1 is our final state, hence we will round it with the double circle, and Q0 is our initial state. Clear? So in this lecture, I discussed how to design the DFA diagram to check the given binary string is divisible by 3 or not. Clear? So I hope everybody understood. So still if you have any doubt regarding this, then please post your doubt in the comment section so that I will provide solution for it. In my next lecture, I will discuss another example to design that DFA diagram for this. Thank you.